Dear students, welcome to our today's lecture. In this lecture, we are going to learn about the encoders and multiplexers. We already know about the decoder and demultiplexer. The encoders are exactly opposite of decoder. How? In our encoder circuit, if there are n inputs, then there are not input, if there are n output, in that case we will have 2 to the power n inputs. So here in our case we will have 4 input and 2 output, that is 2 to the power n input. And this encoder is called 4:2 encoder. This is our 4:2 encoder. So what one encoders do? So if I want to speak very easily, if I give any input, there are numbers, that is, this is input 0, then input 1, input 2, and input 3. This one is input 3. Now, if I put any input at any of this input, that is, if I place 1 here and 0 in rest of the inputs, 0, the output will be the binary of this 1, that is 0 and 1, and this output we mark them as y1 and y2. Let's say y0 and y1. So if I put here 1, so the output will be 0 1, and if we, let's say we make this 0 and we give input 1 here, if we put 1 here at I2, the output will be then not 0 1, the output will be the binary of 2, that is 1 and 0. So if I want to see a truth table of it, we will have like this. Let's say I3, I2, I1 and I0. For them we have the output, that is y1 and y0. If we have 0 for all the inputs, then the output is don't care, that is, this scenario is not possible in case of our encoder. The output is don't care. And if we put, that is 0 0 0 and 1, the output is equivalent of the binary of 0, that is 0 0 is the output. If I put 0 0 1 0, the output is equivalent of 1, that is 0 1. So what about 0 1 0 and 0? So this is I2, so the output is 1 0, and in case of I3, 1 0 0 and 0. You are right, the output is 1 1. So what is the internal circuit of an encoder, 4:2 encoder? The internal circuit for y1, the output is, if we have 1 at I2 or if we have 1 at I3, so the output of y1 is 1. So the internal circuit will be like this. If this is our 2:4 encoder and these are our inputs, so the outputs are the internal circuit. So y1 equals to I2 or I3. If anyone, I2 or I3, if any one of them is 1, our y1 will be 1. That is our y1, that this is our y1, the y1 will be 1. And for y0, the input is, if the input I1 is 1 or I3 is 1, that is this one is I1. If I1 is 1 or I3 is 1, then we will have our output y1, y0 as 1. In all other cases, the output will be 0. So now just try to give input in each of the input lines and match whether this circuit outputs this truth table or not. I hope you all will understand. I1, this is I2, and finally this is I3. So now to try to give input in these inputs according to this truth table and see whether the outputs are according to this truth table or not. I hope you all will understand how this encoder works. Okay, so this is our encoder. This is 2:4 level encoder. So what if we want to draw a bigger encoder? What will be that? We will have 3 output, and so how many input will be there? There will be 8 input, that is 2 to the power 3, that is 1, 2, 3, 4, 5, 6, 7 and 8. This is 3:8 encoder. 3:8 encoder. So if I put 1 here, so the count is 0, 1, 2, 3. So output will be 0, 1, 1. Okay, so we count our encoder like this. If we have one input here, here is 0 and here is 1. So what will be the output then? The input is I7, so the output will be 1, 1 and 1. This one will be also 1. Okay, so this is our encoder. Now the question that pops up in our mind, that what if we have 2 1, here is 1, or we all 4 are 1, what will be the case? That is called our priority encoder. So let's talk about that. Let's talk about priority encoder. So what is a priority encoder? If we have input in more than one line, then what will be our output? In that case, we have to set the priority. What is the priority? Let's say we have an encoder like this. We have a 2:1 encoder. Okay, I0, I1, I2 and I3. So I0 and this one is I3, and our output is y1 and y0, y1, y0 and y1. So in our cases, in these cases, let's say our this priority is higher for I3. That is, if we have any input in both I0 and I3, in that case we will have output according to the I3. The priority is like this. I3, the priority of I3 is greater than the priority of I2, the priority of I2 is greater than I1, and the priority of I1 is greater than I0. Okay, so now what will be our case? So let's deduce a truth table for our cases. We know how to get a truth table. Okay, let's go here. So this is our truth table. let's say we have made a small mistake here. Let's ignore this. The sequence will be, this one is I3, this one is I2, this one is I1, and this one is I0. Now what will be our case? For if we have input 0 in all 4 inputs, our output is don't care. Now if we have input just one input, that is in I0, our output is 0 0. For if we have input as in I1, our output will be 0 1. Now in this case we have input in both I1 and I0. Now the priority of I1 is greater than I0, so output will be according to the I1, that is 0 1. Here the input is 1 0 0, that is 1 in I2, so the output will be 1 0. And again here the input of I2 is 1, the input of I0 is also 1. So what will be our output? Our output will be according to the input which have the highest priority, that is I2, that is the output is 1 0. Here is also we have input at I2, 1 in I2 and 1 in I1, so the output will be 1 0. Here we will also have output 1 0. And here in all the 8 cases we have 1 in I3, so I3 has the highest priority, so the output will be 1 1. I think you understand why the output for all these 8 cases are 1 1, because I3 has the highest priority here. 1 1. Now what we have to do, we have to deduce the equation for this y1 and y0 with the help of K-map. So let's find a K-map for our cases. Here we have a 4 variable K-map. Now if we want to draw a circuit for this K-map, if we want to map this output in our K-map, so we will have I3, I2 and I1, I0. So for our cases for y1, this is the K-map for y1. Now for if I go through this truth table, the first one is cross, don't care, then 0 0 0. Here it is 0 0 and 0. I am just putting a dot for the zeros, and the rest are 1. So 1 1 1 1 1 1. Now if we try to group them, we all know about K-map. We have our first group like this, and we have our second group like this. So what will be the output for this? If we want to write now our equation for this K-map, we'll find y1 equals to for this so what will here for this first group, the below the lower group, we will have I3 as 1, right? 0 0 0 1 1 1 and 1 0. That means we have I3, and for the upper group, the group with this 8 1, the variable is I2. So we have our equation y1 equals to I3 plus I2. Now what about the cases about y2? So now we have to draw another K-map. So let's bring another K-map here. Let's write here I3, I2. I1 and I0. Now if we want to put the values in the truth table, that is cross, then 0, then 1, 1, 1, 1, then again 0, 0, 0, 0, 0, 0, 0, 0. Then again the rest of 1, that is 1, 1, sorry, 1, 1, 1, 1, then 1, 1, 1 and 1. Now if we make a group here, the first group is this one, and the second group is with this 4 variable, that is this one and this 2 1, with this 4 1. So now I hope you will be able to write the equation for this. The equation is for y2, for this A group, for this larger group, the equation, the variable term is I3, and plus for this 4 group, let's see here in this 4 group, the variable, the first variable, that is I2 is 0, here I2 is 0, here I2 is 0, so I2 prime, and for these two we have I1 as 1. Okay, so I2 prime, I1. You all know how to solve this KMF. So we have our Y1, sorry, this is not Y2, this is Y0. So these two are our equation for a priority encoder having I3 as the highest priority and I0 as the lowest priority. I think you will be able to draw the internal circuit of the priority encoder. Okay, so that is the priority encoder. We will have some examples in our example video about the application of this video. Now let's see about some multiplexers. What is a multiplexer? Multiplexer. So what is a multiplexer? Multiplexer is, you can deduce a multiplexer with the help of an encoder. That is, we know about demultiplexer, but in case of multiplexer, this is the opposite of the demultiplexer. That is, this is like this. We have a, let's say, 2 to the power n input. We have 4 input, and we have 2 selectors, that is S0 and S1, and we have only one output. So this one is the output, and these 4 inputs, let's say there's a I again, I0, I1, I2 and I3, and the selectors are S1 and S0. We all have inputs in I0. We all have, let's assume we have inputs in all these I0, I1, I2 and I3. Now this selector will select that which input will go to the output. Let's say we have input as 0, 0. If we have 0, 0 as input, then the first input, that is I0, will go to the output. We will get I0 in the output. Whatever input is in the I0, we will get that in the output. The rest will not come to the output. If we have input as, let's say, 1 1, so, or 1 0, if we have input 1 0, then 1 0 is equivalent to 2. Okay, so we will have output, the input of I2 in the output. So this is the function of a multiplexer. Now, what is the internal circuit of a multiplexer? If we want to draw the internal circuit of this multiplexer, we'll find it like this. Let's draw it in a bigger scenario. We are going to draw the internal circuit, that is S0 and S1, S0 and S1, and we have inputs 1, I0, I1, I2 and I3. Okay, so the first output, this output is, the output is this one. So let me draw first and then I will explain. Okay, so this is the internal circuit of a multiplexer. We have four inputs there. Now, if our input is, let's say, 0 0, so for 0 0, this input becomes 1, this is becomes 1. So this AND gate will be, the output of this AND gate will be according to I0. That is, if we put 0 here, we will get 0 in this AND gate, and if we give 1 here, we will get 1 in this input, okay, in this output of this AND gate. And about the rest of the AND gates, for 0 0 input, see here, for 0, this AND gate, here the input will be 0, here the input will be, for from here the input will be also 0, this input will be 0. I have made a mistake here. Yes, So this is the output. Here the output will be also 0 for this one, and the output of this AND gate will be also 1 for this input. So if we give 0 0, we will select I0 to input I0 for the output. If we give here 0 1 as input, let's say we give here 1 0, that is 1 and 0. In this case, the I2, the output of I2 will get the input of I2 in this output, because in that case all other AND gates, this one and the last one, the output of this AND gate will be 0, and the output of I2 will be passed to the output through this OR gate. Okay, so this is the working principle of a multiplexer, and this multiplexer is known as 4:1 multiplexer, that is 4:1 multiplexer. So this is all about the functions of a multiplexer. We will learn more applications and other solutions of some problem in our example video. Okay, thank you for watching today's lecture.